Hello students, welcome back to our video on chapter 4. We're finishing up binomial distributions. We just did this question where it states that x is at least 1. So at least 1, we wrote it as that way. So just to emphasize why we did it this way, because in a binomial distribution, it's discrete numbers. The values for x can range from, starting at 0, basically x can be 0, 1, 2, 3, 4, 5. X can be 5. X cannot be any number greater than n. So n is 5. That's why we have, we can't go beyond 5. We can't ask for, getting 6 correct questions when there's only 5. So in this case, at least 1 means everything greater 1 or more. So if we were to calculate the probabilities for these all these numbers from 0 to 5, add them up, we would get a total of 1. So we already did the probability when x was 4. We found that to be 0.0146. What I did was I used, I have this Excel sheet. There it is. Let's make it a little bigger. So this is when we calculated in the first part. X equals 4 when n is 5 and p is 0.25. We can do the other calculations. We did this one as well in the second one. When x equals 0, n is 5, p is 0.25, the probability of 0 correct is 0.2373. Here's all the options. X will always start at 0 and will always increase up to the value of n. And here's the probabilities. These 6 probabilities add up to 1. So at least 1 is going to be these numbers in here. And I'll just show you with this simple calculation. We can go equal sum, highlight those 5 numbers, and we get 7627. The same number we got here, 7627. So that is one way to do it. We can calculate the probabilities for each x value, or when it says at least 1, we can go calculate for 0, because 0 is not included in this, and then subtract it from 1. So let's continue our discussion of binomials. A couple other calculations we can do with binomials is we can calculate the average or the mean of a binomial. This is sometimes referred to as the expected number of a binomial. It is n times p. We can calculate the variance and the standard deviation of a binomial. As that, sometimes we'll just simplify the standard deviation of the binomial by looking at it is a square root of the variance, which is n times p times 1 minus p. So the total number of items we have plus or multiplied by the probability of success, and then 1 minus p, and that gives us our standard deviation. So let's look at an example. What's the expected number? Remember, expected number also means average or mean for this binomial. What's the variance and what's the standard deviation for this binomial distribution? We are working on the example, the previous example, where we have 5 questions, and the probability of success on any one question is 0.25 because there's 4 options. For these questions, we don't need to know what x is. So the expected number of for this binomial is n times p, 5 times 0.25, which gives us 1.25. Say you and all your friends were to do this quiz, and you didn't know any of the questions, and you just had to indicate A, B, C, or D for each question. The average from all your friends would be 1.25 out of 5, or 25%. The variance of this binomial distribution is n times p times 1 minus p. So in this case, we're going to have 5 times 0.25 times 0.75. So this equals, the variance would equal 9375. The standard deviation of this binomial distribution is the square root of the variance. We could write the square root of 5 times 0.25 times 0.75, but we already have that number, so it's basically the variance, the square root of 9375, which will equal 96.9682. That is the standard deviation for this binomial. So what we're going to do now, we have a bit of time. We're going to go into the course package. This is on page, let's see what page we're on here. We are on page 59. We're going to look at doing part of question 2. The experiment consists of rolling 4 dice. We'll do part A, C, and D. So A is exactly 2 dice. We'll show the number 3. C is probability of at least 1 dice, showing the number 3. And D is the expected number and standard deviation of this binomial. So the number 3 here is meaningless. We could be looking for any, success could be any one of the 6 options. So let's go here, erase this, and write what we know. We know that this is 2A on page 59. We know that n equals 4. There's 4 dice. The probability of rolling a 3 is 1 out of 6. If you want, you can convert that to a decimal 0.16 or 0.17. There's going to be some rounding differences. And x, in this case, we want to know the probability of 2 of the dice, exactly 2 of the dice, showing the number 3. So the probability that x will be 2, meaning 2 dice, showing you roll 4, then what's the probability that 2 of those 4 dice will show the number 3? We have 4C2. We have 1/6 as our probability to the power 2. And then we have 1 minus 1/6 or 5/6 to the power 4 minus 2. So to the power 2 as well. Our numbers here will be, we have 6 times 0.0278 times 0.6944. So total probability of 0.1157. So there's a 11.57% chance of 2 of the dice showing the number 3. So let's go into part C. Part C asks for the probability that at least 1 of the dice will show the number 3. So we want at least 1 of the dice. So remember the shortcut to do is we subtract the probability of 0 from 1. Because 0 is not included in at least 1. So we want everything except for 0. So 1 minus the probability is going to be 4C0 times 1/6 to the power 0 times 5/6 to the power 4. So 1 minus 4C0 is 1, 1/6 to the power 0 is 1, 5/6 to the power 4 is 4823. So our answer is going to be 1 minus 0.4823, or an answer of 5177. So basically a 51.77% chance of at least 1 out of the 4 dice showing a number 3. In part D, let's just change colors here. Part D asks for the average or the expected number, and that uses that formula. So here we have 4 dice, 1 6 is the probability. So basically this would be 2 6, or 2/3 I should say. I'm just going to round that up to 0.67. And E is the standard deviation for this. The standard deviation is the square root of the variance. So variance is 1 times p times 1 minus p. So here we have the square root of 4 times 1 6 times 5 6. And this would equal the variance of, after we take the square root, 7 4 5 4. So there may be rounding differences. I used fractions and a little bit of help from Excel, but if you're using 0.16 or 0.167 or whatever for your probability of success, your answers will vary slightly. So that is it for chapter 4. Just a few type of questions to do. The probability of for a binomial. Remember, a binomial is we are taking a small number out of a larger number, just like a combination, where we want to know the probability of 2 things happening out of 6, for example, or 3 things happening out of 7. And this is the type of questions we will be asked. What's the probability of x being 3, for example? Or what's the probability of x being at least 1? And then calculating the average or the expected number of that binomial, and then the standard deviation of that binomial.